When it comes to mesh deformation, a good topology is a crucial characteristic. Before we do anything though, let's see the two objects we're going to deform and figure out the best way to remesh them for our purpose. These are the two animations we're going to create in this tutorial. For the water animation, we're going to use a collection of spheres which are notorious for having bad topology for deformation, but because we're merging them together like metaballs, they're going to be remeshed in geometry nodes that it's going to look okay. As for the enamel pin, we'll need to use the remesh modifier, apply it, then unwrap the mesh to apply our textures. Let's create the two objects. For the water animation, we'll create the mesh and animate it using geometry nodes. Then we'll add a few modifiers on top, including the curve modifier. Let's add a new geometry node tree. And in there, we'll start with a UV sphere and we'll keep the default values, then plug in and distribute points on faces with a density of 1. In the original animation, the points move along the normals of the points, so we should start by storing the normal of these points. The type is going to be a vector and the domain is going to be a point, and because we're original, we should name it normal. In order to move those points along that stored normal, we need to multiply it by a value. So let's add a vector math node and choose multiply, input a named attribute node of type vector using the normal values we stored, and let's plug it into the offset of a set position node. This is not interesting for what we're creating, so let's randomize it a bit. We'll add a 4D noise texture that is animated using a scene time node, slowed down a bit by dividing the frame by 24. And you can change that value to fit the speed you like. Plug that into the W value, then plug the noise texture's factor to the second value of the multiply vector math node. Instead of the values going from 0 to 1 though, I want to map it between -1 and 1 so the points intersect. I need them to go in and out of their original position rather than just out. So let's add a map range node after the noise texture with those values. To regain some control over how big that movement is, let's add a scale node between the multiply and set position node, and set it to 2 or whatever value you think looks cool. But because of my framing, I think 2 is fine here. We don't really want points, so this calls for a good old instances on points. The instances will be a UV sphere with a radius of 0.1 initially, as we'll randomize the instances scale later on. Let's next realize the instances, plug that into a mesh to volume, then a volume to mesh, and these are my settings. I only changed the density and voxel amount a bit. I don't really have any explanation for why. I just looked at my mesh and decided what it needed. Next is my favorite bit, which is set shade smooth. You don't have to check it as we work, but it's important for render. If you look closely at my final animation, it's not even that smooth, but I found the values I chose worked with the speed of the bubbles. So while it's animating, you're not actually seeing those sharp edges. Attach that to the geometry socket of the group output node, and this is already working nicely. But let's randomize the scale of the instances using a float random value node. These are my values. Input that into a combine XYZ and then into the scale of the instance on points node. The reason I do it this way is to keep the scale uniform. Otherwise, with a vector, you're going to have lots of ellipses rather than spheres. You can move on to the next section from here, but of course I went a step further, adding another set of instances that are a bit smaller to add some variation. I used the same initial UV sphere, added the new distribute points on faces, and changed the seed so we get a different set of points. Then I made a huge mistake of storing a new set of normal values under the same name. So I overwrote one of the two sets of normals. You should definitely store one for the bigger spheres and another for the smaller spheres under two different names. I used the same noise texture to multiply the smaller spheres normals by it, then scaled it by bigger values so they can pass the bigger spheres since they're going to be smaller. This is all visual, so don't worry too much about the specific values, but I'm going to show you them anyway. And if you want to get the exact same animation, you're going to have to make the same mistake as me by overwriting the normals. I then plugged that into the offset of another set position node, added an instances on points node with a UV sphere as an instance. You can use the same UV sphere we used for instances before, as we're randomizing the scale for that as well. So duplicate the random values and combine XYZ, change the values of the random minimum and maximum to smaller values. These are my settings if you're curious, and plug that into the scale of the instances. I also added a join geometry, of course, before realizing the instances, and joined the two instance on points nodes, and that's it for the geometry nodes. We can finally move on. And just a note, if you feel like you can create this animation with just curves, feel free to do so. But I preferred using the geometry nodes just to make things much easier to manage later on. Okay, usually a mesmerizing animation has multiple subtle animations built on top of each other, creating a more interesting dynamic. You can 100% continue the animation in geometry nodes as well if you like, but I'm going to move on to modifiers now. The first modifier we'll add is a displace modifier with a cloud texture. These are my settings for the texture because I want a subtle change. And of course, the bigger the cloud texture, the smaller the changes in the mesh. Now, the problem with the default settings of the displacement modifier is that they don't move the displacement, and I'm looking for some extra movement as the object moves through the curve. So to move this cloud texture displacement as the bubbles move, we can use an object coordinates. We'll add an empty, then pick it as the object. This allows the displacement to move since it's centered around the empty rather than the object itself. I'll also add a subdivision modifier to smooth the displacement, and finally the point of the tutorial will add a curve modifier. Since it requires a curve object, let's create a random one. I just created a curvy one that moves right and left on the x-axis. I like to make the curves subtle so you don't get weird deformities in the mesh as it goes through sharp curves. So the smoother your curve, the better it's going to look. And I use the pencil tool to draw the curve after deleting the initial Bezier curve points, but feel free to use the pen tool or any of the other tools in the curves edit mode settings. I'll use the negative z value as the deform axis, which means I'll animate the object along the z-axis for it to move along the curve. To know which deform axis to choose, start with the direction of the curve. Mine is parallel to the z-axis, so I start from there. If that doesn't work, make sure your object's scale and rotations are applied. And the second major tip for the curve modifier is to align the object's origin with the curve's origin. That's why I like to start with both objects in the center and later move both the curve and the object to the final location in the scene once you're done with the animation, ensuring that the object never shifts from the center of the curve. And that's our first object done, modeling and animating wise. Let's move on to the second one, working through an enamel pin. To start, I have 4 different images for the pin. One is all black. The second is the main color with no strokes and a black background. The third is for metallics or for choosing a different color for strokes. And the last is for a displacement, which is the same as the metallic, but slightly blurred for a smooth displacement. There are multiple videos on this. I like Neoplastic's Cinema 4D enamel pin tutorial because they use a simpler shader structure than the one that I found for Blender. The black image isn't really an image. I exported it as an SVG because it's going to be our mesh. The other 3 I exported as images for color and displacement. I'll repeat the same thing I usually do with any SVG I import to Blender, which I've showed multiple times. Decimate the faces into planars, then extrude the curve and convert it to mesh. And finally, we can remesh it. Then here, I'm going to apply the remesh modifier because I need to UV unwrap it in order to put the textures on. The remesh settings will depend on the object you're creating, so don't rely on the numbers I have. Now unwrap it in front view by hitting U on the keyboard while in edit mode and choosing project from view, because we mainly care about the front face of the pin. Before we do anything, let's create the 2 material slots, one for the front of the pin and one for the back. For now, just give them different colors and select everything on the mesh but the front faces and assign it to the second material. We do this first because it's easier to select vertices before we add rotations and animations. Otherwise, you'll have to disable everything in order to add your textures in UV Unwrap. Here's where things differ a bit from previous tutorials. When it comes to the remesh part, for the pin, I added an extra modifier, which is the triangulate modifier, just to make the mesh look a bit nicer and to get more points in between the original points without subdividing even more with the remesh modifier. That's all I needed to do before I added a curve modifier. For this one, I created this curve because I wanted the object to move towards and away from the camera. I used the Z value for the deform axis. Sometimes with the curve modifier, it's a trial and error situation, so don't get discouraged. Then I animated it on the Z-axis to move it along the path. And I finally added a subdivision modifier to smooth the vertices further. It's time to set up the camera, add some lighting, and finally textures. For both, I set up my camera resolution at 1080 by 1920 for vertical video, and by default, I have a focal length of 85mm. I also add an empty, call it focus, position it where I want the focus to be, then use it in the camera's depth of field section in the object's data properties. Adjust the settings how you see fit. I set up my f-stop at 1.2, depends on your scene of course. I then add a plane for the background. There's also a slight difference in the focus position between those two animations because I moved the camera for the bubbles animation. The focus in the bubbles animation moves along the curve using the clamp 2 constraint, so I can use the copy transforms constraint on the camera to copy the empty's location. And I added a slight noise to the rotation of the camera, while in the enamel pins camera, I kept it still. As for lighting, it's separate for each object, except for the shared modern bathroom HDRI from Polyhaven at a strength of 0.4. I set it to 0.4 because I want to add extra area lights, and because my background is light, the full power of the HDRI is too much. For the water bubbles, I added an area light for the background with an initial strength of 500 watts. The area light uses nodes where I plug a noise texture with these values into a color ramp, then scale it by whatever values for an appropriate strength for the scene. I had to scale the strength of the resulting noise texture by 3 for this. And if this doesn't work for you, the one reason I found light textures don't work for many Blender users is because they don't reduce the light spread. I have mine at 3 degrees because I want it crisp. If you want the light texture to look slightly blurry, go with values from 10 to 30 degrees. Now for the enamel pen, I added 2 area lights, one for the background and another for the object, for an extra shine as it moves, because I found it a little bit flat and I wanted to accentuate the movement of it with the light. The one set up for the background has a strength of 1000 watts and uses nodes to add a Voronoi texture to the emission strength. I crunched the color with a constant color ramp, then scale it by 0.2 to lessen the harshness of the light. And I set up the spread at 30 degrees to show the texture with some blur. And the one for the object shines a slim rectangle light from the top on an angle with a spread of about 90 degrees and a strength of 100 watts, acting kind of as a key light. Time for my other favorite bit, texturing. For the water bubbles, let's add a new material. But since it's a geometry node's output, we have to add a set material node at the end of the tree right before the group output and set it to the new material. I called it glass. This is the glass texture you'll see many Blender users apply, and it's quite simple. We'll remove the principled BSDF and add a glass BSDF instead. To add the dispersion to it, we'll need to duplicate the glass BSDF 3 times for the 3 color channels. RGB or red, green, and blue. If you switch to the RGB tab inside the color settings, you'll easily create a red by setting its value to 1 and removing all of the green and the blue. Do the same for the other 2, one for green and another for blue. Now we'll add them together to create the dispersion look. Insert an add shader and combine the first 2 channels, red and green, then duplicate the add shader, plug the first one into it and add the blue channel. And plug the result into a mix shader where we'll combine the plain glass BSDF using the transmission depth from the light path node as the mix shader factor. Nothing really changes now until we start shifting the channels by changing the IOR. Most will change the red to 1.45, the green they'll keep as is, and the blue they'll shift to 1.55. Feel free to experiment with the higher differences and see what happens. It's just shifting the blue and the red. Also, depending on which channels you shift, you'll get different colors. As for the pin, we can adjust the textures that we applied earlier. For the background, we'll add a slight bump with the noise textures using the object's texture coordinates. Since our UV is optimized for the object's front view only, feel free to use your own settings, but these are mine. The front seems slightly more complicated, but it's like any other imported texture. We have 3 components to focus on: the main color, the secondary color, and the displacement, which is the same as the secondary or stroke color with some blur, as we said before. The easiest to add is the main color, which you can plug into the base color of the principled BSDF. At this point, you can also change the color with some hue and saturation. If you set your colors right, you won't have to do that. Then the displacement goes into a displacement node. Depending on your blur, you'll adjust the scale. Mine is at 0.02 with a mid-level of 1 to push everything out. Remember that displacement doesn't really work correctly unless you change the displacement settings under the Material tab from bump only to displacement and bump. And the reason we're doing this is because we're adding a bump. Otherwise, just choose displacement only. You can add a bump to the normal like we did with the back of the pin, but you don't have to. And lastly, we add the stroke color, and that goes into the factor of a mix shader. The first shader is the one we plugged the main color into, and the second is another principled BSDF with the same bump if you like. Choose your favorite color and roughness, or make it metallic. It's up to you, and we're really done this time. Except for one more thing, before you render the animation, remember to set the output path in the output properties to your desired folder. And enjoy. Talk to you later. Bye.